How's it going, everyone? Joe Fairley here from Ascent Fabrication. Today is June 16th. It's actually Thursday. It's not our Fabrication Friday today, but I wanted to kind of get one day ahead here because I will be going on a nice hiking, backpacking, camping trip this weekend and taking a well-needed day off this Friday. So I wanted to record this for you guys beforehand for Fabrication Friday. And I'm also making up for what was missed last week for Fabrication Friday because we have some exciting news, coming forward here. The Filament Innovations 3D printer that you see here on the screen right now. I went to their location in Pennsylvania. Those guys are great to work with. Mike Gorski and his team are fantastic. You definitely have to check into their operation there. They've got some very large printers, some of the largest that I've ever used before. And we're going to be working together moving forward to help to explore more of the high flow 3D printing and its applications in prosthetics and orthotics. So today I wanted to kind of give you guys an overview of some of my knowledge in terms of which 3D printers you may or may not want to look at when it gets to what type of prosthetic or orthotic clinic you have. Do you want to do this in-house? Do you want to use a central fabrication facility like myself? And again, some of the reasons why you would want to do one over the other. And then kind of point you in the direction in terms of if you wanted to go more the hobbyist level, maybe some of those 3D printers that some people are using right now in the field. So without further ado, we're going to go through a few 3D printers that I have found with the largest build volumes in order to kind of print the larger scale things that we're doing in prosthetics and orthotics, whether it be a test socket, protective cover, ankle foot orthoses, some larger AFOs out there as well, and some other items as well. So we'll start out with the Filament Innovations Icarus here. The Icarus has a lot of great componentry on it from Dye's Design. Their high flow Typhoon extrusion system really spits out a lot of material in terms of the extrusion speed because of the larger nozzle sizes and how the extruder is made up. They're able to produce devices a little bit more quickly depending on the print type that they're doing, whether it's in vase mode or non-vase mode for the 3D printing status there, specifically when we're talking about prosthetic sockets. Here the build area is 460 by 380 by 950. 950. I did pull up a millimeters to inches tab just to go back and forth for people here. So 950, we are talking about 950, that's 37.5 inches of build height here in the Icarus model. That's quite impressive. Definitely, what we would need to see here in the prosthetics and orthotic space, moving forward for some of the larger applications, which may include, scoliosis, TLSO body jackets in the near future. I know there's some people out there right now who are exploring that with different materials. Filament Innovations CPX copoly polypropylene material is extremely durable. Definitely check that out if you're looking for a preparatory socket out of CPX material, or looking into lower limb orthoses and or scoliosis body jackets. We will be doing quite a bit of work in the next few months looking into these devices as well and determining their viability for printing. So when you're looking at very high grades, this printer is going to work right from the get-go, and you have the support to back it up. Filament Innovations, Mike Gorski, these guys are great to work with. Check them out. We'll move on to one printer that I also currently have in-house right now, the PVA Med Emergence Pro system. They have a 480 by 330 by 635. They put it into inches here for you as well. So they're up to 25 inches in build height. definitely usable for most applications in the field right now. They are more so just focusing on test sockets strictly from PVA med at the moment. So that is just one thing to think about for looking at their solution currently. Um, Looking on into another 3D printer that I have here, the Raise 3D Pro 3 Plus. I've used Raise 3D printers now for the better part of 6 years. Raise 3D has done a nice job to bring the hobbyist level up a notch in terms of a little bit more, worry-free 3D printing from a large volume 3D printer. So their starting cost here at about $7,600. A little bit more feasible for some clinics to bite that off if you're looking for a 3D printer that's a little bit lower scale. Maybe you're not quite ready for the more industrial 3D printing, but you want to get your toes wet. Raise 3D may or may not be for you. Taking a look at, I'm going to try to find, oh yeah, their print volume was actually up at the top here. Sorry about that. We're looking at 300 by 300 by 605. So not as wide of a print space as the Filament Innovations printers or the PVA med printers, which may limit us in some cases for lower limb orthotics. I have printed lower limb orthotics AFOs and SMOs on this printer with PP Prints polypropylene material and support material. And honestly, with their dual extrusion system, it has handled it very, very well with their specific P surface as well to reduce and minimize any warpage possible. So they do have a nice solution for a kind of lower price point at the moment for dual extrusion. Again, you're really going to get what you pay for in terms of the levels of cost for these machines. My Raise 3D machine has, caused just a couple issues here and there where I've had to take a look at some of the parts and think about, replacing them as time goes on for consumables. I don't think I'll have as much of an issue with the Filament Innovations, Icarus or Kratos printers. So again, things to consider when we're looking for what level we want to get into the 3D printing space. When we're looking at a different type of 3D printer here, the Tractus 3D has caught my eye recently for its larger scale 3D printers that they have. They advertise 23.5 inches in build height for their kind of mid-level T1250 3D printer here. They call it their desk series, but this is a pretty tall printer on its own. This comes with a full cart system that you can see here. But it's one of the Delta printers. So it's a different type of printing process that, you use a circular build volume, which just has its own little nuances when you're trying to set something up for a print. For something with a little bit more width, if we're looking at maybe a lower limb orthosis, might not be the best application for this specific printer. Tractus 3D, though, also has some much larger printers. They have this behemoth of a printer, the T3500, that you can print 82.5 inches tall. They just keep increasing the rail system on this, and as you can see here, they're I don't know, maybe printing a rocket ship or something like that. So this is just to give you guys an idea of kind of what's out there. I'm sure their larger build volume comes with a larger price tag, so things to note there. In more of a almost semi-hobbyist level here, we do have the Lulzbot Taz Pro XT, coming in at a price point of even lower than Raise 3D at $5,500. Definitely might be a little bit more on the lower end, again, replacing some consumables more often than others. You're only using 2.85 millimeter filament with this printer. So, that's a consideration. Different filaments will have different filament diameters, and not all filaments will have both diameters. So that's something to consider as well. We are looking at a build volume here of the 23 inches for the Lulspot Taz Pro XT. So again, probably pretty usable in terms of build height for most items. Prosthetic covers, possibly. I don't know if you're going to fit so many large AKs on this, depending on how wide we get there. But, again, more considerations to think about when you want to think about getting into 3D printing for your practice. How large of items am I going to be looking to print? How many different materials do I want to print? Am I going to want to print flexible materials? Some 3D printers work better with flexible materials than others. If they have a direct drive extrusion system, that's going to work better with flexible materials. So again, those things are definitely ones to consider when you're looking at a 3D printer to purchase for your practice. When we're talking about 3D printers that are in-house for central fabrication purposes, maybe we're thinking about footprint. Do we need a lot of 3D printers in one space? Most of these 3D printers are fairly low footprint, so we're not really too worried about that. Getting them through a commercial grade door, again, not something that we really need to worry about here. But that's just kind of a, really brief overview of, what different large build volume 3D printers are available. Here again from Filament Innovations, the Icarus 3D printer, the PVA Metamergence Pro, the Raise 3D Pro 3 Plus, the Tractus 3D T1250, Lulspot Taz Pro XT. Again, kind of going down in order from more industrial to more hobbyist level. Underneath the Lulspot Taz Pro XT, there might be a couple other hobbyist, printers that are about maybe the same build volume as the Lulspot Taz Pro, but with lower end consumable hardware. You will be changing out that hardware a lot more than you will with some of these other 3D printers, and you're likely to have less support on the back end from those companies in terms of using their printers and third-party materials. So really things to think about when you're wanting to automate some digital workflows within your space, in your practice, and how much hands-on time do you really want with one of these printers. If we then take a look again at some of the printers that I have in our space, we'll do a little tour again. So we're going to take a look at first. We do have the PVA Med Emergence Pro 3D printer that is going on about a 26-hour print right now for a protective cover. That's in a light skin tone TPU material. We've had to utilize different print surfaces depending on the material that we're using. So again, the materials, extrusion systems, whether it's direct drive or a Bowden tube system, are things that we need to think about. Print surfaces, materials again that we're using, nozzle sizes, et cetera. By now we've talked about quite a few of these little nuances, so I won't get too far into the weeds with those today. But again, there's a lot of considerations when you're getting into 3D printing in your space. The FL Sun Super Racer has been another kind of desktop 3D printer with about a build volume of about 13 inches tall. That's been definitely usable for some use cases. I am printing our seat leg covers on this FL Sun Super Racer. So, again, some smaller covers you might be able to use for that case. Then we're going to take a look at the Raise 3D Pro 3 Plus. It has a really nice large display system there, touchpad screen for a lot of different print settings that we would use. Looking in towards some of the hardware, we do have a dual extrusion system. The print bed is actually a build tack print bed. So the build tack is just one of the surfaces that has a high coefficient of friction, and surface area for a lot better bed adhesion. So yeah, we have the PVA Med Emergence Pro, the FL Sun Super Racer, and the Pro 3 Plus from Raise 3D. One thing to consider too with some of the materials that we have, they are hygroscopic, so they actually take up water from the air. And I would consider purchasing over there in the corner the Print Dry Pro from Matter Packers. It is a filament drying system where you can actually route cabling directly into your 3D printer if you're looking to dry and print at the same time, which I do quite a bit of. Because our dry materials are going to be easier to print with, and we're going to have better surface quality if we are drying our materials as we go. Yeah, so all in all, I just wanted to give you guys a brief overview of some of the large scale 3D printers that are available right now on the market. Last time we talked about, what type of scan is a good scan. So we're kind of going down the line in terms of, how we get from a 3D scan of our patient to a device that can actually be made within our clinic. We have the 3D scanning, bunch of different 3D scanning options. If you haven't heard of Comb yet, I would go check out Comb on an iPhone 10 or newer. It's the lowest price point, most detailed, easiest to use 3D scanner that I've seen so far on the market. And again, with our high flow 3D printing from Filament Innovations, I would definitely consider taking a look at these guys moving forward. They're really pushing the boundaries for material space as well as build volume and printer quality for the hardware involved. We're going to be looking at a lot more different applications in the clinical space for prosthetics and orthotics with this machine here in the near future. Again, one reason why you might want to send Ascent Fabrication some of your files to print, if you are evaluating whether or not you want to get into 3D printing in your space, that's a good way to get started with us, is to look for the viability of something that you want to print. Do a couple use cases with some patients, see how it goes, and then we kind of move on from there. And Ascent Fabrication can also, help you get up and running within your own clinic. So yeah, guys, I just want to thank you again for taking a look at this Fabrication Friday. A little bit of a short video clip today, but I wanted to make up for last week, and actually put something out this week for sure for you. So any questions about these 3D printers or others, please don't hesitate to reach out. Visit our website at ascentfab.com or reach out via email, joe@ascentfab.com.